Well, hello, friends. Today we are going to work a little bit on crash messages. So I got this bug report here from Faisalu. I don't know how to say that. Faisalu, I guess, saying that it would be kind of an improvement or a cool improvement if instead of just saying you crashed trying to read this address, it would give you a little bit more information, like you may have tried to dereference a variable containing a null value. I think that's a little bit on the overly hand-holdy side, maybe, um, but um, but I think that we can certainly do better than what we currently do. So what we currently do, I'll show you, is that so I have a crash program that I wrote in an earlier video. We'll just do a regular segfault. And then what we see over here in the debugger output is that, so this is the crash address, and then here's the backtrace below it. And we also have more information up here that it's an unrecoverable page fault. We are trying to write to this address. So I think that we can do better than this. So I'm just going to take this. So he has another suggestion here as well, which is that like, oh, the address is very large and it's unlikely to be valid. Your program may be corrupting memory. Yeah. All right. So I'm just going to take this because I think the idea is good, but I think these examples are like a little too coddling for my taste. So I had some other ideas here, which that would be that we check if something looks like uninitialized memory, or if something looks like recently freed memory, or if we are close to the end of a valid memory region. And then there's a little bit of skepticism here, but I think that we can definitely do at least the first two of these quite easily, because all that we really need is to look if the pointer you're trying to access looks like it's uninitialized or recently freed memory, because then the allocator will actually go and I call it scrubbing. So after you malloc, then we'll put the byte hex 85 in all of your allocation, and then when you free, we'll fill it with 82. So it would be easy to just check if a pointer, for instance, if like we're crashing because of a pointer dereference that starts with 8585, that's kind of suspicious, right? So I was thinking we could do something like that. Likewise with 82. And it would probably be better actually to scrub with bytes that are higher than C0, because that's where the kernel would start. So let's just say, because then we know that they're never going to be valid user space regions, so we're going to need to use some higher numbers here. So how about DC and EB for free? Okay. I guess that's pretty cool. Right. So we're gonna need a rebuild to get that effect. But let's just start on, maybe we start by making this message here like a little bit more noticeable. Because right now it's not really sticking out. Like, I know to look for it because I got so used to looking for this one. But earlier today I added the colorized crash address thingy here, and it would be kind of cool if this information would also be a little bit color enhanced. So these page faults are definitely like the most interesting crashes from a user perspective, because those would be your most common types of crashes when you're writing traditional C or C++ code. Of course, there are ways that you can write defensive code so that you get less of them, but you're still going to get them. So Let's see. Let's maybe start with just colorizing this thing here. So, wait, what the heck did I do now? I didn't want to do any of that. So let's just print it on the debugger to start with, and then we can put, maybe we put this in red too, or let's see. Yeah, let's just do the whole thing in red. So it's 31 and 0 to turn it off, right? And now I'll put this in red, and maybe we can do something interesting with the pointer here. So fault address is using this ancient coding style, which I'm just going to go and change right now. Because otherwise that was going to annoy me. Okay. So that's the fault address, blah, blah, blah. Okay, now we can say something like if fault address and FFFF, let's say like that, is and let's see. So let's put these outside of the header so that we can, I mean, let's put them outside of malloc CPP so that we can at least pick them up. Oh dang, where are we gonna put these? libc malloc that, I guess malloc.h is fine. Let's just have a malloc.h. Who's going to stop us? Pragma once. And we can put that in there. Or I'm going to say malloc.defs.h. malloc.defs. Yeah. Close that, and we'll include malloc.defs. Okay. And then in the kernel code where we crash, we can say if it's the oh, we gotta include it. So it's libc malloc defs. Wait, what am I doing? Okay, so the default address top bytes are malloc scrub, let's call it pattern. Maybe malloc scrub pattern. I'm struggling to type here because I just came from work and I have a different keyboard at work. But I just put it in order for the same exact keyboard that I have at home. So then at least moving between home and work isn't going to be so jarring. Luxury problems. Let's see. So this would be malloc. Wait, what the heck is it called? malloc scrub byte. I mean, I guess I don't really have a way of doing this. I never knew that I wanted to have this thing, but maybe I do. Let's say template. Or no, let's just do, let's call it explode. Explode byte. Byte B, I guess. Put this up here. And then it's just going to be B 24, B 16, B, oops, what am I doing? and B, or B actually. Can I? Or no, it's because the stupid automatic integer thing. Well, it doesn't matter. Int always fits. Okay. Let's say. I mean, I should be good about this and say like const xperm and static assert explode byte. See, that's good, right? And let's just to be sure. Wait, what am I trying to do? I'm trying to do this. Just to make sure that we're not falling for any traps here. All right. Normally I wouldn't be so paranoid, but I am a bit tired. It's the end of the day. It's better to make sure if you're not feeling super confident. So we'll say explode byte. And this would be free scrub pattern. So we'll say if we're faulting at the address looks like it's a recent malloc, we'll say in yellow note address looks like it may be recently uninitialized malloc. Like that. And I'll say the same for oops. Oh, I recently learned Control J in CubeCreator. Boom. Will join forward with the current line with the next line. Just like capital J in VI or in Vim, which I am really used to doing in Vim. And it was something that always annoyed me that I couldn't do in CubeCreator, but then it turns out all you got to do is Control J. So I'm very happy about discovering that. Let's see, recently freed. I guess we can really do this because otherwise we wouldn't catch sort of bigger dereference offsets, but this way it will probably catch most of them. Okay, so I think that's kind of an interesting thing. So let's add a crashy thing. Let's add something to the crash tool for this. So so the crash tool is like this little command line utility that allows you to crash in different ways. So we have these modes here. So we're going to add a new one called M and a new one called F. They're going to be for malloc and free, respectively. So dereference uninitialized malloc memory and freed memory. Okay. So those are M and F respectively. Dereference uninitialized malloc memory, dereference freed memory. Okay, and then we'll say dereference uninitialized malloc memory. And we'll do something like I guess void star is, or no, hold on, char star is malloc 1024. We'll call it uninitialized memory. And we'll do it this way. Maybe even this way. And then we can say dword, or rather uninitialized memory 0. I mean, we can write to that thing, but we can't treat it as an address, so I'll do that. Maybe we'll try to just try to get it out. So X is that. Can you say volatile auto? Does that make sense? I guess so, because volatile is just CV qualifier. Curious. Okay, we'll have to rebuild everything anyway. But then we should also actually do the freed memory, dereference freed memory. So in this case, we do free uninitialized memory and then try to read from it. Okay. And that did not work out because my password is different today. I guess we could even have two separate ones of these. Could have write to and read from variants. So let's see, write to. Oh no, these will be the lowercase ones will be the read from, and then we'll do uppercase ones as well. Fancy. Okay, so we're almost there with the compilation. Just gonna make this second mode, or this extra mode here, because it's also very useful to see if you were writing or reading or writing when you're crashing. So let's do read from and read from. Oops, that was not what I wanted to press. Write to. Let's do this. Just because I'm paranoid. Paranoia is always a great reason to use volatile, right? Oh, whatever. No matching function. Call to. Really? Oh, that's so interesting. Well, screw paranoia then. We'll see if it works anyway. So we just wanted to write to it. Oh, and it's still running here, so we can't make the disk image. And sudo sync. We'll see how this goes. Oh, we had some other problem down here, but never mind that right now. So crash M. Well, the color didn't come out right, but otherwise I'm kind of Something is right, but the color didn't turn out right because we forgot to do the M here. So let's try that one more time with the fix. I think it'll be more interesting. Crash M. Okay, so it looks like it may be uninitialized malloc memory. That's rather cool. Oh, we screwed that one up too. Oops. Let's see. Okay. See, now we're talking here. Looks like it may be uninitialized malloc memory. That's very cool. So it was a read. See there that it's a read. Okay, and then let's try the other one. Crash M. Assertion failed. Line 86. Okay, so we kept going here. That's stupid. So, or actually, oh, I see what my problem is. Shouldn't try to mess with auto too much. Okay, because we don't want the compiler to optimize out these obviously bullshit assignments. Because in this case, we actually want, oh, I forgot to sync. Sync is the step that copies all of the compiled code and compiled programs into the disk image that I use for testing. Sometimes I recompile something and I don't use the sync script, and that means that when I try to run a program, it's not the copy that I want to be running. Okay, so write. It looks like it may be uninitialized malloc memory. Pretty cool. Okay, and what was the other one called? F, right. So that's just asserting. Oops, that's not what I wanted to do at all. And that one is asserting as well. So the freed memory things. Read from freed memory. And let's just do that in all the cases. So why is this not working? Let's do printf freed memory. We'll do x wrote to freed memory at uninitialized memory 0 0. Oh, user line is what I want. Very suspicious. Okay, it's getting a little bit warm here, so I'm just gonna nudge open the window a little bit. Okay, so why are these not right? Are we actually doing the scrub, I wonder? If scrub free, and it's true by default, so we should be scrubbing. I mean, up here we don't actually scrub when we recycle a big block, but I don't think this would be a big block. Curious. Well, I'm probably just screwing this up anyway. So let's see, we're calling free on this. and then we are actually using it. I guess this is really what I wanted to show, actually. Man, summer is getting warm here. Wait, what's the one I wanted? So that's very weird. Like, why is it not, got milk memory at? We're gonna figure this out. Before free, this is, I mean, that's just the same as the other guy. Okay, I'm just having like a tired brain problem right now. Why can't I brain? So the pointer itself is going to be the same. It's what's in the pointer that matters. So it's what the thing is pointing to that matters. So this is the thing that matters. Nah, I forgot to sync. Okay. So that's the value that I'm looking for right there. That's the guy that I want to write to. Uninitialized memory 0. And I'm trying to write to it here, but it's not happening. Am I just being really dumb? How do you do this thing? I need to like force this thing to be in order or something. I mean, this is so cheesy. I just don't know what I'm doing wrong, so I'm just gonna force it to put these statements in order. So forget about that one. Wait, before free, it's DC DC. Oh, hold on. So DC is the malloc scrub byte, that's the uninitialized memory. What's it after free? After free, it's something entirely different. Why? All right. I'm so confused by this. Okay, well, I'm just gonna scrubbing free. Let's say putter. And we'll make libc. Oh, I guess we have to rebuild libc actually. This is gonna get kind of loud. Or, well, we can just rebuild the crash app. Crash. Okay, so got that. And we scrub this. And after that point, what? Why am I struggling with this so much? Okay, what does the other one say? Read from freed memory. So this is what we wanted. Mm-hmm. Wow, I'm having such a brain breakdown right now. What the hell? Why are these behaving this way? Is the pointer still the same? Like that. So the pointer is the same, but after the call to free, there's an entirely different value inside of that array. I'm so weirded out by those. Okay, I'm gonna do some hyper paranoid shit. Is this how you do this? Oh, I don't remember. Pragma, GDC, optimize. I mean, I guess I have that somewhere in the code. Yeah, so that way, okay. I'm just ignoring it? Why are you ignoring me, bro? That you liked? Okay. Okay. Free. What? Okay. So putter. We're setting putter to ed, 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 ed. I would have thought. Oh God, I'm so stupid. There's a free list. Malloc is using a free list. It's right here. This is the very next thing that it's doing. It's the free list is intrusive. So it's just overwriting my scrubbed out bytes with freaking free list bytes. Oh, what do you want, phone? Well, so I guess we're just not going to get that one right now, at least not without changing the way the allocator works. And I'm not going to do that. But I am going to leave all of this screwing around in the video because sometimes it's good to see other people struggle. Okay. So then I guess we can just kind of forget about this stuff actually. Or, oh wait, hold on. The free list, the intrusive part of the free list is only at the start of the freed area. So we will not scrub the first entry into the array because that will be the pointer to the next entry in the free list and the malloc memory free list. But we will certainly screw up the fourth entry, so we can do those. Okay, that's, which one was that? That was uninitialized malloc memory, right? F, recently freed memory. Look at that. Let's do the small one too. Recently freed and uninitialized malloc. Okay. Oh, damn. All right. And then what was happening with just seg crash s. So let's see. I guess we can do a little bit of a Codely output for fault address. If the fault address is less than, if it's like within the first page, then we can say something like, looks like, I don't know, dereference. I'll call it a null putter dereference. That's kind of cute. Oh, and we should actually put these here too. I even forgot to print them out. Interestingly, they were in the right stack location anyway. But we should definitely be putting them, we should definitely be passing the arguments to the function correctly. So let's see. Yeah, so now looks like a possible null putter dereference. Kind of cool, right? I think these are going to be helpful. Probably. Yeah. Okay. So let's do a patch review. Wow, this is the most tired I've been programming for a long time, actually. You can probably tell. Okay, so we are including malloc defs, which we need to get at. Let's see, malloc defs. Okay, and then we added that little hack here to explode up a byte. I mean, that should probably be in a more general place. So I'll put that in types ACK types. Just like that. Okay. Then we are just changing the style here so that it doesn't use this ugly old camel case. Very important. Okay, and then we're colorizing the unrecoverable page fault output a little bit. And let's see. This just makes me realize that we can do write to versus read from. Make it a little more clear what's going on. Write from virtual address. I'm just trying to make it as maximally understandable as super possible. There's a dot at the end of that one. The other ones didn't have dots. Capitalize. It would be nice to have dots though. But at the same time, it's nice to not have dots. Read from. Yeah, that's pretty good. Pretty good. And what's the other one? That's pretty good too. Write to this address. Yeah. Oops, that's not the one I wanted to close. All right. So that here are all the new modes for the crash program, in which I flailed around quite badly, but we eventually figured out what the problem was. I can actually show you what the malloc data structure looks like for the free list. So it's a very, very simple free list that whenever you free something, so the allocator is kind of, I think it's called like a slab allocator. It's probably not called a slab allocator, but it's like or it's not strictly a slab allocator, but it's a block based allocator that uses size classes. So if you ask malloc for 16 bytes, it will take 16 bytes from a block that has like this dedicated chunks for that are like the closest fit to 16 bytes. I'm not explaining that very well, but anyway, when something is freed, then it goes into the free list of that block, and the free list is just a linked list of these pointers, and then we cast what was previously the allocation. Like when you hand it to free, then it will just cast it to a free list entry and put it at the header of the free list, I think, and then just point next to the previous head, and that's how we are able to make malloc very fast, because you're always mallocing out of a free list until you run out of free list, and then you have to create a new block. Anyways, that's the data structure. Right, so I think that's the whole patch, really. So I think I'm just going to commit this. I'll say kernel plus libc. Make crash messages, or at least page fault crashes a bit more understand or readable. What was that bug number? 243. Added some, also added some color to the most important parts of crash log to make them stand out. We'll now try to detect crashes that were due to dereferencing uninitialized memory, malloc memory, recently freed, and null pointers. We can put that first. It's not perfect, but I think it's pretty good. Cool. And added some more modes to bin crash for exercising the new crash logging. Exercising this code. Nice. Okay. I think that's pretty good. So let's push that. And I guess we can look at it one more time. Should look into what that thing is later, but not right now. Okay, and then we'll crash. Look at that. Write to this suspicious address. Looks like it may be uninitialized malloc memory. Very, very cool. All right. So I think that's going to be it for today's video. If you made it this far, then I thank you for watching and hanging out, and for coming back. And I hope to see you next time.